Hello everyone, so happy to meet you all again. In our last video, we have seen what is called limit of a function at a given point. So let me tell you first the flow of the topic. So we know what is called function first of all, then we see what is called limit of a function at a given point. Then from this we just move to continuity of a function at a given point. Okay, from the continuity then we will move to differentiability of a point of a function at a point. So this is the flow of the topic. See children, in 11th NCERT they have discussed limit and they discussed differentiability. In 12th NCERT they have discussed in detail about continuity and differentiability. So it is wise to go in this flow. So we have already seen what is called limit of a function at a given point. Those who haven't watched that, just watch the previous video. So from this we will move to continuity. So today we will see what is called continuity of a function at a given point. Once we have done this, then we will move to differentiability of a function at a given point. Is it fine? Okay. A small quick recap. So what is called limit of a function at a given point? So you will be given a function and you will be given a point in domain. So to check whether for this function at this point the limit exists or not, what we have to do? Yes, we have to find LHL, that is left hand limit, and we have to find RHL, that is right hand limit. And if they exist and if they are equal, they are finite values, and if they are equal, then we say the limit exists for a given function at a given point. All these in detail we have seen in last video. Okay, now we are going to continuity. Before going that, why to check the continuity of a function at a point, why it demands the existence of limit. So why we have to learn limit before going to continuity? Is that necessary? Yes, it is necessary. Okay. Similarly, if we learn continuity only, then we can move to differentiability. Within few seconds, so you will know why it is necessary that the existence of limit to discuss the continuity. Okay. So children, so simply saying what is called continuity or what is called a function is continuous. A very rough intuition is you are given one function. Okay. So you just look at the graph of the given function. If your graph of the given function is continuous, it looks continuous, right? Or I can say, see, you can draw this graph without picking hand from paper. Am I right? Yeah. Your given function looks like this continuous, then we can say the function is continuous function. Yeah, it is a very rough intuition. Okay. So what is called, as I said earlier, whatever definition we learn, we have to learn the negation of that too. So what is called, we say this function is continuous. What is called negation of this statement? That is not continuous function. Not continuous means not continuous. We can use mathematical term that is called discontinuous. Okay. See, now look at this graph. Okay. See, this is also a function because for each input there is the output. Okay. So it is a function. Is this a continuous graph? No, of course. It is very explicit. Am I right? Because there is a break in this curve. So when there is a break in this curve, we can say this is a discontinuous graph. This is not continuous graph. But look at one thing, dear children. Now this is the whole domain. Okay. But now I restrict my domain only up to this. I restrict my domain only up to this. Now in this domain it looks continuous. Am I right? Do you see the difference? In the previous long domain, I had a graph like this, so there was a jump. So I said there is a break at this point in this domain. So it was a discontinuous function. Now I restricted my domain. Within this domain, it looks continuous. So it depends on the point. What are the points we are having in domain? So it is necessary. Okay, let me explain to you a simple example. See, in our class, there are 20 students. I am saying every student have scored above 90 plus marks. See, when my statement is true, if each one of the 20 students have scored above 90 plus only, then my statement is true. Suppose 19 students have scored above 90 plus, but only one student have scored only 85. So in that case, is my statement correct? No, isn't it? So when my statement is correct, if each one of the 20 students have scored above 90 plus, only my statement is correct. Similar to that, here continuity, we check point wise. Okay, in each point the function should be continuous, because in the previous case only at this point, corresponding to this point only, there is a break. The remaining points, if you eliminate this point from domain, the remaining points and all, the function looks continuous. So it is correct that to check the continuity at a given point. See, it is something more abstract. Let me tell you why it is. See, I am giving you a curve. Is this curve continuous? Yes, of course there is no break, it is continuous. But say, is this curve continuous? Yes, it looks continuous. Is this curve continuous? Yes, it is continuous. Is this curve continuous? Yes, it is continuous. Is it? Yes. So now I am breaking into smaller and smaller and smaller, and at certain point I will end up with dot, a single point. So, and I am checking whether at this point the function is continuous or not. It is what I said, more abstract. When you are given a long piece, and you can, it is more visible that it is continuous. But when the function is given at a single point, I am asking at this point, is the function continuous or not? See, within this interval the curve is continuous. Within this interval the curve is continuous. Within this interval the curve is continuous. So I'm breaking into smaller and smaller pieces of this domain, and finally I'll end up with a single point. At this point, is the function continuous or not? So this is what I said, checking the continuity of a function at a single point. The same thing we did in, likewise we did in limit of a function. Am I right? We have taken only one point, and at that point we check whether the limit exists or not. Similarly, in this case also, we take a single point in a domain and we check whether the given function is continuous at that point or not. So now, suppose your function is given within this domain. When I can say the function is continuous function? You check the continuity of the function at every point of the domain. At every point, if your function is continuous, then I can say in the whole domain the function is continuous. Similar to that, in our class, everyone have scored 90 plus, then I can say the whole class have got above 90 plus. Am I right? Just similar to that. Every point the function should be continuous. Then we can say the whole given function is continuous. Okay. So this isn't all the very basic thing before I am giving you the definition. Now let me give you a formal definition. See, you are given one function and you are given one point in a domain. And now we are asked to check the continuity of this function at a point x is equal to a. What is the definition? To check the continuity of this function at the given point, we have to, first of all, we have to get two things. The first thing is, just get the functional value at that point. So function is given, input point is given, so you just get the output value, that is f of a. F of a is called what? It is called a functional value at a point x is equal to a. This is the first thing you have to get. What is the second thing? You have to get limit of the function at a. You have to get limit of the function at a. So there are two things. One is you get the functional value at this point and you get limit of this function at the given point. So this will be some number and this will be number if it exists. If both of these numbers are equal, when the case it exists, then we can say this function is continuous at this point. I think, dear children, now you can see that the very first question I asked, right? Why we need existence of limit to discuss the continuity? Am I right? Look at the definition of continuity. What is the definition of continuity? Functional value and the limit of the function at that point. Both these values should exist and they have to be equal. When they are equal only, we can say the function is continuous at that point. So to check the definition of continuity itself, we need the existence of limit, right? So First of all, limit has to exist at that point and get the limit value and get the functional value. If both are equal, then we say they are continuous. Suppose in case, because in previous lecture itself we have seen in some functions at some point limit itself may not exist, am I right? So when limit does not exist, can we discuss about continuity? No, it is meaningless, am I right? It is meaningless because when the limit itself doesn't exist, we can go to this definition. If it exists only, and we can get this value and we can check whether they are equal or not. So when limit does not exist, it is meaningless to talk about continuity, isn't it? Yes. So now let us take a small example and we shall see that. Check that. Say you are given a function f is from R to R. Say f of x is x squared function. See, I have to check the continuity of this function. Say at x is equal to 3. Okay. Look at the graph of this function. It is a polynomial, am I right? It is and then it is an upward open parabola, am I right? You might have studied all these things in conic sections chapter, am I right? Yeah. So the points are here, okay, say 3 is here. Now I have to check, see, obvious, when you see the graph, it is continuous. See, in calculus, it is always more efficient to get the graphs first, because by seeing the graph itself we can check the limit, continuity, even differentiability. So many problems we can resolve just by seeing the graph. So whatever simple graph you can learn, just try to learn it, because see this, now by seeing this, its graph itself, it looks the function is more continuous at every point, am I right? Because there is no break. Of course, from that itself I can say the function is continuous at 3. But let us check algebraically how to do it. So we have to find two things. One is functional value at 3. What is functional value at 3? F of 3, that is 3 squared. 3 squared is nothing but 9. Am I right? Next, we have to check the limit of the function. What is the function? X squared. Limit of the function x squared at 3. Am I right? So what is the limit of the function at x squared is equal to 3? That is nothing but 3 squared, that is 9. See, for doing this, we have to practice many problems in limit functions, okay? I assume that you have practiced all these problems and you are doing this. So now look at here, in this case, see, it is because it is polynomial, right? So you can simply do it. Your functional value at 3 is 9 and your limit of this function at 3 is also 9. So here f of 3 is equal to limit of x squared at 3. So since the functional value exists, the limit value exists infinite and they are equal. So I can say the function is continuous at 3. Is that fine? Yeah. Now, let me do a small modification in the same function. See, my f of x is x squared if x is not equal to 3 for all the remaining numbers, real numbers. If x is equal to 3, say my output is 10. Say for 3 alone, my functional value is somewhere, it is 10. Okay, 10. Now look at the graphs. See, by seeing the graph itself, you can understand there is a break corresponding to this point 3 into y, right? So here itself we can say the function has a break at 3, so function is discontinuous at 3. But let us say algebraically, what is the functional value at f when x is equal to 3? Your functional value is nothing but 10. But what is the limit of the function at x squared? When it is a polynomial, you can directly substitute it. Am I right? Because polynomials are always a continuous function. You can make a note of it. Whatever polynomial, whatever may be the polynomial, but polynomials are always continuous from R to R. Okay. So since it is a polynomial, the value is 3 squared, that is 9. Look at in this case, here functional value at 3 is 10, but the limit of the function at 3 is 9. So in this case, the functional value is not equal to the limit of the function at 3. So in this case, we say the function is discontinuous at 3. That is, the function is not continuous at 3. So dear children, we have to work with so many different examples, then only we can understand this topic. So to discuss the differentiability of the function, of course, your continuity is must but not sufficient. So regarding all those things, we will see in forthcoming videos. Thank you. If you have any doubt, just mail to us. Thank you.